Hello Year 12 and welcome to the next video here for the normal distribution. We're looking at 1105, the shape of a distribution here. The shape of a distribution. We're talking about what sort of pattern the data forms if I draw up a bit of a frequency polygon or a frequency histogram and draw a curve over them. Right? The shape that we're looking at. Now we referred to very early on in this topic the normal distribution as a bell curve because the shape of it is this bell sort of shape. So this shape is what we would generally call a normal distribution, and it's symmetrical. It's the same on either side, right? They sort of balance each other out. If it should sort of lean one way or the other, we would call that skewed. Now the skew tends to occur because we have more scores sort of stacked up here, or more scores stacked up here, which is what causes it sort of bulge on one side. A really nice explanation I've heard someone use is imagine that here in the middle we have like a wall, and I have a rope dangling over the wall, and somebody is pulling on that rope on one side. Right? When somebody pulls on that rope, right, you can see someone on the positive side of the wall is pulling on that rope, and it's caused it to sort of bulge up there or pull up. Here, someone is pulling on the rope on the negative side, so my sort of bulge is on the negative side. This is negatively skewed. This is positively skewed. Okay. Now, when that happens, our median and our mean slip away from the mode. So the mode is the most common score, the score with the highest frequency, and in our normal distribution, and it's symmetrical, we have the mean, median, mode all in the middle. But once I introduce a bit of skew into the data, right, then the mean slips sort of towards the side of the skew, and the median to a lesser degree moves that way. Okay, so symmetrical, negatively skewed, positively skewed. It's important that we recognise those things. We might have more than one peak in our data or a cluster. So a peak is sort of like a high point. It doesn't have to be the highest point. If I have something like this, right, I can say I've got sort of 3 peaks there. Even though this is not the highest point, it's not a mode. It is nonetheless still a peak. And sort of around each of those peaks, we can refer to those things as clusters as well. I tend to use the word cluster rather than peak, and they both tend to refer to very similar things. Now, don't know what's going on there, doesn't matter. We've got an example here. Go away. Right. We have an example here. We're going to describe the distribution. We're going to describe its shape and smoothness. Maybe it's smoothness. We'll talk about that when we get there. Any clusters and the number of peaks. So here we go. We have a stem and leaf plot. Now this, of course, means I've got scores of 31, 32, 43, 45, 49, and so on. My biggest score here is 99. This gives us a bit of a rough idea. It can sometimes be a little misleading, but I can see that generally speaking, in the high 70s and 80s, I have a lot of scores here. So it looks to me as though we've kind of got this sort of thing going on, which looks like a negatively skewed distribution. Oops. So this looks to me to be a little negatively skewed. That's the first part. From there, let's say negatively skewed. Right, because it's as though it's sort of being pulled on at the low end, at the negative side, or the smaller side. Negatively skewed, smoothness. Don't worry about it for the time being. Any clusters? Well, I don't think we'd sort of... Could we say that we've got a cluster here? I don't think it's necessarily borne out. I wouldn't be inclined to say that I have an obvious cluster there. Righto? So I would not say that there are 2 clusters there, although some people might. I've got an obvious sort of peak here. Yeah, written like this, insufficient to say that there's a peak there. I wouldn't say that. But I certainly have a peak here, and I would say I'm inclined to say 1 peak. If we used, if instead of doing these by individual scores, if I broke it up into grouped data of 10s, so all the 30s, the 40s, the 50s, the 60s, 70s, 80s, and 90s, then I guess we would have, we would have each of these would be a column, and there's there's only 2 scores in this column, there would be 2 scores in this column and 3 in between. But really, you only need 1 more score there to make that a sort of smoother curve. I'm pretty reluctant to call that a peak. Right? They're fairly spread out. Over here, again, I have a skewed distribution, but it looks like it's being pulled on the positive side, right? I've got a bit of a bulge on the positive side, so that's positively skewed. Right? Any clusters? Not particularly. Peaks? Look, this here is higher than either side, this one and this one, but when I look at that data, do I say I've got 3 peaks? You've got to use a certain amount of common sense with these and say, how much variation is there? How significant is that? If we repeated that, if I took a bigger sample, would I get the same sort of peaks? Maybe, maybe not. I'm inclined to say that, look, we've put this curve over the top here, right, to smooth things out, and that says that we only have 1 peak, right? 1 cluster and 1 peak. 1 cluster. I'd be reluctant to describe it any other way. This is a different story, okay? Now, the sort of gap from here to here, here to here, and this is very much up and down. It's certainly not smooth, and these are certainly identifiable peaks. Right? That's quite a multiple. I've got 1 here, I've got 5 here, I've got 6 in this column. I think 6 times the previous column. We can certainly say that's significant. So, is it symmetrical? It is symmetrical. Do you know about 6? So it's symmetrical. Oops, 2 M's in symmetrical. Symmetrical. We have, I would say it's not smooth. I can't put a neat curve over that. I have 4 clusters, 4 peaks. Seems fair enough. And over here, now this is pretty smooth, right? I've really got this sort of thing going on there. We curve over the top. That would look to be skewed. Now, is that positive or negatively skewed? Yep, so that's going to be sort of pulled on at the positive side, positively skewed. And it's smooth. No, there's no real ups and downs there. We have just 1, do we say 1 cluster? Really, we want to use the term clusters when we have more than 1. Okay, but we can say 1 cluster, 1 peak. Okay. Wonderful, and I think that's it, righto? That is the shape of a distribution. They're relatively straightforward. The most important thing is identifying positive and negative skew, to be able to describe that, and maybe to be able to say what that does to the mean, okay? My mode here, right, my mode is at the high point, but my mean is going to be shifted over towards the skew side. Right, something like that. So it's important to recognise that. Skewness, the separation of mode, median and mean when that happens in terms of clusters and peaks. Sometimes that's significant. In a lot of these examples, it's not really. Anyway, that's it for this video. Hope you enjoy. I'll see you in class.